this is the question from analog circuits, and this is a very tricky question in fact. So this is given, this circuit is given, and the breakdown voltage of Zener diode is given as 5 volts, and 5 volt is given as the breakdown voltage of the Zener diode, and we have to calculate the time, okay, when V naught will reach to minus 10 volts, when V naught will reach to minus 10 volts. So if you are able to analyze the data very carefully, okay, this is going to be very simple question. Okay, when V naught is going to be, let me change the color here first. When V naught will reach to minus 10 volts, okay, what will happening actually? Okay, just analyze this circuit. Okay, since we know that this circuit, okay, the positive terminal is grounded, okay, so this terminal voltage, okay, let me, it's va is going to be also grounded 0. Okay, so when V naught will reach to minus 10 volts, okay, this both the capacitor will have equal voltage because they are connected in series actually. Okay, so when Zener diode is not in breakdown, they are connected in series. So here it is going to be charged to be plus minus 5 volts, and this will also have equally same voltage, this also have 5 volts. Okay, so V naught is going to be minus 5, and minus 5 is going to be 10 volts. Okay, so indirectly the question should be like this. Okay, calculate the time interval when Zener diode just start in breakdown region. Okay, and if the question was like this, okay, this is going to be very simple. Okay, so they frame a question like this. Okay, V naught equal to minus 10 volt, calculate the time interval. Okay, so when V naught equal to minus 10 volts, just so we will calculate the voltage at this point. Okay, Vc1 equal to minus 5 volts, because we know that this voltage is going to fix once it is going to be in breakdown, this voltage is going to fix. Okay, so one more thing what you can analyze here, okay, that this inverting terminal voltage is 0 volts. Okay, when you connect this switch, okay, at t equal to 0, this is 1 minus 0 divided by 1k, 1 milliampere, a constant current is going to flow through it. Okay, a constant current is flow through like this. Okay, 1 kilo ohm resistance, this capacitor and this capacitor, both the capacitor is going to be charged. Okay, and just when this voltage just reach to 5 volts, okay, Zener diode will go in breakdown. Okay, and that time you have to calculate. Okay, so let me do it here. Okay, like this. Okay, I is going to be 1 volt minus 0 divided by 1k, so it is going to be 1 milliamperes, like this. Okay, and we know Vc1 is going to be how much? Okay, that is 1 by c, and minus infinity to t. Okay, and I dt, so it is going to be 1 by c and 0 to t, because before time t equal to 0 current is 0. Okay, so 1 milliampere dt, and that is going to be 1 divided by c, and c is given as 10 to the power minus 6, 1 microfarad, and this is going to be 1 milliampere, so it is going to be outside, and this is our t, 0 to t, so it is going to be 10 raised to power minus 3 into t, and divided by 10 raised to power, 10 raised to power minus 3 here. Okay, and this is going to be 10 raised to power minus 6 here, so it is going to be 1000 t Vc1. Okay, so what is the time when Vc1 reach to 5 volt? V naught is going to be minus 10 volt. Okay, so 5 volt is going to be 1000 t, so t is going to be how much? This is going to be 5 milliseconds. So this is a very easy question. If you are able to analyze the data carefully, this is going to be very easy question. Okay, so see you in the next video. Thank you very much. Have a nice